All right, guys. So again, I'm going to repeat one more time here. Okay. So the process in which, okay, that you are, okay, that you're using this enzyme TPO to so-called oxidizing this iodide is known as, or this is one of the roles that TPO does, which is converting into so-called iodine. Okay. There is one other role of TPO. Okay. Now, then we have to come back that other thing that these follicular cells do. Remember, follicular cells are so-called functional unit of your cell, functional unit of your thyroid glands, right? What they do is they are known for synthesizing something called thyroglobulin, okay? And guys, you have to remember, thyroglobulin is not a thyroid hormone, okay? It's a precursor of your thyroid hormones, okay? That is something you have to remember. Because the thyroglobulin is what is known as something called colloid, okay? The colloid basically means a thick proteinaceous molecules, okay? It has large glycoproteins that is inside this lumen, okay? It's just a thick protein, you can remember that way, okay? And thyroglobulin is a large glycoprotein. It has about like a 335,000 of like molecular weight or so, okay? But anyways, as I said, one of the functions of this your follicular cells is to synthesize thyroglobulin, okay? But that synthesis of thyroglobulin is highly regulated by your hypothalamus, okay? That's why we're discussing about hypothalamus. So now, if you guys come back here, if I see this is my hypothalamus here, right? Now, if you see this is, okay, this is my hypothalamus, this is going to be like, look, this is, you guys already know, this is going to be my anterior pituitary, and you can say this is the posterior pituitary, okay? And remember, this in hypothalamus is a different nuclei, right? I'll just write in some of the nuclei. This could be like, let's say, paraventricular nuclei, okay? Paraventricular nuclei, okay? And let's say these two are my, let's say, arcuate nuclei, okay? Arcuate nucleus. That's what it is. So remember, your synthesis of your thyroid hormones are regulated, highly regulated by hormones that is coming from the paraventricular nuclei and also from the arcuate nucleus, okay? So, and also from the median eminence, okay? Because they release, okay, let's say this paraventricular usually release so-called your somatostatin, okay? So that's what it releases, somatostatin, right? Meaning these ones are, it gives a negative feedbacks, okay? So that way it doesn't secrete like too much of TSH. Okay, we'll talk about that too. And this arcuate nucleus and the median eminence, they are the one they are important for secreting so-called or synthesizing and releasing with these vessels, okay? Okay, these are going to be paravascular neurons, and then with this hypothalamic, okay, you guys know this, hypothalamic, hypophyseal portal vessels, okay, they are going to secrete out something called TRH. What is this? Your thyroid releasing hormones, okay, that is coming from your hypothalamus, which is from here, from the arcuate nucleus, okay. They come and go to the so-called your anterior pituitary, okay, because the anterior pituitary has like a lot of different cells there, okay. They have cells for growth hormones, they have cells for prolactins, but here they have, but where here I only drew one cells, and these cells are going to synthesize so-called your TSH, okay. What are they going to secrete? TSH, which is so-called as your thyroid, okay, your thyroid stimulating hormone, okay. That's what these guys do. Alright? Now, these cells which secretes the thyroid stimulating hormones, these are called thyrotropes. These cells are called thyrotropes, okay? And they appear to be basophilic, okay? So whenever these thyroid hormones, thyroid releasing hormones secretes from hypothalamus, it comes from these vessels, which is a hypothalamic, hypophyseal portal vessels, and comes to this so-called your anterior pituitary, and anterior pituitary cells, which are called thyrotropes, they have receptors for this so-called your thyroid releasing hormones. So let's just make this quickly, okay? If I make this, let's make this as so-called as your one cell right here, okay? So whenever this cell comes in here, okay? So let's talk about this. Whenever this TRH, let's say the receptor over here, okay? The TRH comes in right here, okay? And then this is my thyrotrope cells, right? What is it called? Thyro, okay? It's called thyrotrope cells, okay? It binds to the receptor here, and this is a G protein receptor, okay? It's a G protein coupled receptor. But this is a GQ pathway, okay? It's leading a GQ pathway. And then I'm not going to go super detailed about it, okay? But you guys know this. GQ pathway leads into, okay, activation of so-called phospholipase C. And phospholipase C does what? it cleaves your PIP2, which is phosphodiethyl inositol biphosphate, and breaks down into so-called your IP3 and your DAG, right? And DAG further activates so-called as your protein kinase C, right? And this IP3, what it does is develop these granules, okay? These granules contain so-called, let's say, TSH, okay? The TSH hormones right here, okay? Let's say, and then what happens when the IP3 comes in, or this protein kinase C, put a phosphate group into this, what happened? These started coming down here, okay? And it started this, because of the calcium, it started going and started fusing on the cell membrane. And when it starts fusing the cell membrane, it will become, this is my TSH now. And then these TSH goes to the circulation. And these TSH goes, and then this TSH, which is a thyroid stimulating hormone, they have receptors located in your follicular cells, okay? So these thyroid stimulating hormones regulates, okay, let's write down a couple of things. It regulates so-called your proliferations, okay, and synthesis of your so-called your thyroglobulin, okay? That's the result, TG. It also play a role in your secretions of your so-called your T3 and your T4, okay? That's what the role of those thyroid stimulating hormones, okay? And we'll talk about the detail about this one, okay? So this is how usually, okay, this hypothalamus play a role. So we can call this as, okay, hypothalamus. This is so-called hypothalamus, okay? Hypothalamus, this is pituitary, so hypothalamus, pituitary, okay, and that's thyroid. This is my thyroid gland. So you can say this is a hypothalamus, okay, pituitary thyroid gland axis, okay, that's what they call, because we're talking about the hypothalamus, anterior pituitary and thyroid gland, okay, so it is again hypothalamus, anterior pituitary thyroid gland axis, okay, they call this out. Now after this, okay, remember this TSH has receptors on the follicular cells, okay, to synthesize so-called your so-called your thyroglobulin synthesis, okay. So whenever TSH work comes here, let's say the TSH comes here, okay, and TSH binds here, what is that going to go? TSH binds here, okay, with this receptor. But remember one more thing, TSH has a receptors here for both, okay, they're both G protein receptor, okay, but one of the pathway is going to lead into the GS pathway activations, and then there's the other one which TSH has a receptor which is going to lead into GQ pathway, okay. So usually GS pathway right here is going to talk about TSH by G protein receptors, and remember this one is, let's say, we're not going to go super detail about it, but remember eventually what is going to happen is that with the TSH, with the GS pathway activations with the alpha, right? And then it's going to go to this adenyl cyclase, okay? And then it's going to activate the domains of the adenyl cyclase, and then later it convert ATP into so-called your cyclic AMP, right? And the cyclic AMP further activates protein kinase A. This is going to put a phosphate group on the nucleus here, and then also it's going to activate the genes to do a proliferations and secretions of so-called your thyroid globulins, okay? But if TSH comes and binds into the GQ pathway, usually that leads to the activations of the secretions, okay? That is something that I wanted to quickly emphasize here too, okay? So again, TSH has both a receptor. It has GQ receptor also and GS receptor also in your follicular cells. GS is going to lead into proliferations and synthesis of your thyroid globulin. You can think about thyroid hormones. You can think about that way. The secretions, okay, taking how much, okay, this one and just throwing out of the circulation, that is going to lead by the GQ pathway of your GQ pathway, okay? That is something that I quickly emphasize. This is just extra that I'm giving it to you, because again, you always get extra here, right? Okay, anyways. Now, this, guys, okay, this, let's say this thyroid hormones get released in the circulation in extracellular fluid. Okay, from there it's going to go to the so-called your thyroid follicular cells. And then obviously with the protein kinase A, okay, it's going to activate certain genes, right? So if I make this, okay, this is my, let's say, this is my nucleus right here, and this is my nucleus right here, and this is a gene to, let's say, synthesizing so-called your thyroglobulins, okay? So let's say synthesize the thyroglobulins, and then comes and put a phosphate group, okay, and all that, and then it's going to synthesize, and then it's going to make so-called mRNA, right? And then mRNA, it's going to make translate into protein, right? So basically, this is going to taken by so-called here, and this is called like rough endoplasmic reticulum here, okay, and this is smooth, and this is Golgi right here, okay. So this one is, let's say, it's taken by this so-called here, and this one is this in this dot right here. This is so-called, you can think about that as a ribosomes, okay. So whenever, look, this protein, let's say this protein molecules, okay, let's write down the different color here, okay. Let's say this is a protein here, okay, and then one more here, and we have like, okay, this is a gene to synthesize your thyroglobulin, okay, and then, okay, and there's here, right here, and then here, like this, okay, we're just making this couple of things, okay, like this, or you can simply, you can use like that too, okay, and then do different things, okay. Anyways, so basically, and this is a gene, okay, to synthesize so-called thyroglobulin. But remember one more thing, in order to synthesize thyroglobulin, okay, they have to, okay, use some the amino acid, okay, and this is let's say this is a gene to so-called make something called the protein, which is that is required to make your thyroid hormones, and this protein is so-called tyrosine, okay. So right now they're basically what they're trying to make is the residues of your so-called your tyrosine residue. That's what they're trying to make, right? They're trying to make the proteins. And remember, if you guys quickly, if I mention this to you guys, let's talk about what is the structure of the tyrosine looks like, okay? Let's quickly draw that, okay? Usually tyrosine is what? It's so-called aromatic rings, right? If you come back here, okay? It's aromatic rings right here. And then it has, okay, hydroxyl group into it, okay, in a carbon number 4 positions, okay? And then you have so-called 1, 2, and it has NH2 group into it, and then it's a carboxyl end into it, okay? Usually tyrosine looks like that, okay? So you can label this 1, 2, 3, 4, 5, and 6, okay? So basing the 4th position, your hydroxyl group into it, and you have a, okay, this amine group and also the carboxyl group. This is how the tyrosine looks like, okay? Now, and this is basically the nomenclatures of the tyrosine, you know? And now, if you come back here, okay, this is what's synthesizing your tyrosine right now, okay? Now, what is going to happen is that with there are going to be other amino acids as well, okay? But we're going to focus mainly on the tyrosine right now. And then, what is going to happen is that this, let's say this tyrosine, let's say, this residues are, you know, what's going to happen? The ribosomes is going to start reading this so-called, let's say, tyrosine, residues. And then, what is going to happen is that it started taking in, okay, and it started synthesizing the protein, okay, that's what is going to happen, right? That's why in the rough part of endoplasmic reticulum. And then also what's going to happen is that this is also where, okay, dimerizations and glycosylations occur, okay? Usually in this case, dimerizations and glycosylations, okay, let's write it down. Dimerizations, okay, and then glycosylations takes place, okay, in so-called as in your smooth part of the endoplasmic reticulum. Okay, let's say this is rough ER. Okay, and let's say this is smooth ER. Okay, here, and dimerization basically means is that, okay, dimer means 2, right? So basically this tyrosine residues, okay, the monomers of tyrosine residues and the monomers of another tyrosine residue, they're coming together and fusing together, okay? That is so-called as your dimerizations, okay? And then also on top of that, they put a glycosylation, meaning the adding a glucose sugar into it, okay? So that's what that takes place in these both areas, okay? And once it's get dimerized and glycosylated in here, let's say in a smooth endoplasmic reticulum in this case, okay, then after that what's going to happen is it's going to get, okay, shipped to this guy, which is called Golgi now, okay? That's what is going to happen. It's going to go to Golgi. And remember, as Golgi, you guys know that what Golgis are known for packing, okay, packing, making small droplets and then shedding it and sending it, right? So then after that, these guys get packed into the Golgi. And then goes over it kind of packed into vesicles like this, and then it sends it to so-called into lumen. This process of sending into the lumen is so-called exocytosis process, okay? So it is so-called, let's write it. From here to here, this is called your exocytosis, okay? So this Golgi extrude out these vesicles, okay, into this lumen, okay? Or follicular cavity, okay? With the process of exocytosis, because this will slowly confuse and then go into the lumen. Okay, now let's just talk about this. Okay, let's just say this is my one protein here. And this protein, it's so-called as a, okay, this is my, Now, once it's getting dimerized and glycosylated, it becomes so-called as a thyroglobulin, or you can say precursors of a thyroglobulin, okay? So-called, it's a thyroglobulin, okay? That's what it becomes. Now, this thyroglobulin, what is happening, is going to get extruded out to the lumen here. Now, when No, wait now, this thyroglobulin here, let's say it gets excreted out here, okay? When this guy come here, okay, let's just talk about, let's say this is what I drew as a thyroglobulin. Again, TPO also works onto this. Now this is, I drew in here, okay, this structure right here, guys, this is this one, okay? When it comes here, and then this, you see this structure, these are different structure there, okay? These are different amino acids that I'm trying to make. But anyways, okay, or you can say these are the different, let's say, your thyroglobulin subunits, okay? You can say that. Now, whenever this guy comes here, okay, whenever they get extracted out, you know, what is TPO? TPO has another role, okay? What TPO does is that, you know, it plays a role in, then, you know, this iodine, okay, this iodine, it's sort of like, you know, adds this iodine into this so-called tyrosine residue. That's what it does. Okay, so let's say in this compound here, let's say it adds one iodine here, okay? So I'll make one iodide here, okay? It adds it onto this one, okay? That's what it does. And this is, let's say this is a tyrosine. And then here it adds, let's say, two more here, okay? It's just, that's what it makes. That's what it does, okay? So basically, we call this process of, let's say, this adding iodine into this so-called your tyrosine globulin precursors, we call them instead of organifications of this, okay? Let's say organifications of iodine. Okay, that's what is happening. So this process of adding, let's say, iodine, okay, into this tyrosine residue is so-called organifications of so-called your iodine. Or you can simply say that it's iodinations of the tyrosine residue, okay? Or what do you call? You can say iodinations, okay? Iodinations of your tyrosine residues, okay? The tyrosine globulin residues. That's what they're doing, okay? Again, with the help of, this is very, very important, with the help of TPO, what is it doing? It is putting iodine molecules into so-called on your tyrosine residue, okay? So this is called organifications of iodine, or you can simply say iodinations of the tyrosine, so-called tyrosine residues, okay? That's what is happening. Now, so we know the two roles of the TPO so far, okay? One is the oxidizing the iodide molecules and converting into iodine, okay? Other one is the organifications of the iodine. That's what you're doing. Now, once this has it, okay, let's just say this is also, let's say this is, we'll make this as another I, okay? Another I. Okay, this is I here, and then this is, let's say, another I here, like this is another I, this is I, like this, okay? That's what it is doing, okay? Now, one more thing we have to now talk about a little detail here is that, okay, let's just talk about a little detail. So whenever, okay, whenever, let's say, this is my tyrosine residue, okay? Okay, look, this is my tyrosine compound here, okay? Now, I'm going to draw another structure here, okay? Same thing. Okay, let's say this is my tyrosine. You guys know this, right? Okay, let's do a little better, so you can have a good understanding of this, okay? I'm drawing this structure for the better understanding here, right? So let's say, as I said, this is my so-called tyrosine, okay? Aromatic ring, you have 1, 2, NH2 right here, and then you have a carboxyl OH here, right? I'm going to draw 3 more, let's say this one, NH2, and then carboxyl into here, right? And this is my OH group here, right? Again, okay. Okay, look. The reason I'm drawing is, okay, look. And then obviously you guys have a OH in here, okay? Look. Label this, okay? We can say this is 1 position, 2 position, 3 position, this is 4, this is 5, this is 6. Okay, again. 1, 2, 3, 4, 5, 6. Okay, again here. 1, 2, 3, 4, 5, and then 6. Okay, now look, we have iodine. Okay, this iodine, whenever it, let's say, add into, let's say, this position, 3 position right here. Okay, they added 1 I here. Okay, now this is on the tyrosine residue, you add 1 iodine. Okay, now this is no longer as just so-called as it's a, because this is organifications of your iodine, or this is a so-called as your iodinations of your tyrosine residue, okay, because you're adding iodine. See, if there's adding 1 I into this tyrosine residue, that means we call them a mono, okay, it's a monoiodo, okay, tyrosine. Okay, and this is obviously help of so-called as your TPO, okay, TPO, and we simply call this MIT. Okay, they call this MIT. Okay, now let's say not only this TPO this does, TPO also what does it? Somebody combine so-called as this 2I and then puts on the tyrosine residue. So if this is the case, okay, there's a 1I on the 3 position, other one let's say in the 5 position it has. So it is basically 2I, okay, the 2 iodines, look, basically there's a like these iodines are what, this atom, right? So like 2 atoms are coming together, okay, and adding to so-called this on this tyrosine residue. That's what happened, right? So because of that, we call them as this one as because of 2I, we call them it's a di, okay, iodo tyrosine. That's what it is. Or they call it a DIT. DIT. Okay, it's a DIT. So this is what happened, and this is obviously happening with the help of so-called as your enzyme, which is a TPO. Okay, now, and this is just this picture right here. You see, this is just my normal tyrosine picture right here. That's what is happening here. Okay, now after you guys understand this part right here, there's one more that this TPO enzyme does, and that is something called your coupling reactions or conjugations, which basically means is that whenever these 2 iodotyrosine come together and fusing together, okay, it no longer becomes like iodotyrosine, it's going to become so-called iodothyronine. Okay, that's what's going to happen.